Hi there, algebra class. Well, welcome to this lecture. This lecture is on the difference of two squares theorem, which is pretty short and easy. And then I'm going to also talk about a little more famous theorem. It's a classical one called the Pythagorean theorem, which you've also probably heard of. The difference of two squares theorem is a quick and easy one. Let's just knock it out here. It basically says if you have two numbers, let's call them just P and Q. And if P squared equals Q squared, then either P equals Q or P equals the opposite of Q. Think about that. Does that make sense? If you have a number that's the same as the other number and you square the first number, then you'll get that one squared. But if you have a number that's the opposite of the number and you square that opposite, you're also going to get that squared. Another way to think, let's just do a real life example here. Let's say that we have 4 equals x squared. So this is in this format. If I wanted to rewrite it, I could write 2 squared equals x squared, right? Well, then you know that x equals either 2, or if you stop and think about it, there's also another possible answer. X could equal the negative 2, or the opposite of 2. Oftentimes we combine these and would just say x, in that case, equals positive and negative 2. Okay? Pretty simple, right? One thing that you don't do is every time you see the square root sign, like for instance, the square root of 9, you don't just automatically, oh, square root of 9, that equals positive and negative 3. No, you don't do that. Because, see, you're not really solving an equation here. When they say the square root of 9 in algebra, almost always they're asking for just the positive answer, 3. If they wanted the negative 3 or the other, because negative 3 times negative 3 definitely does equal 9. And if they want that negative value, then they'll put this out in front of it. So you read it the opposite of the square root of 9. So then you know to write down that the answer is negative 3. Does that make sense? But don't just brain dead. Don't just go and do that on everything. Okay? It's only when you're solving an equation like y squared equals 169. So you just say to yourself, okay, I want to get y, so I take the square root of that, and I want to get. So if I take the square root of one side, I've got to take the square root of the other side. So then this gives you y, and that is the square root of 169, which then is positive and negative 13. Do you see the difference? All right. So to recap, the square root of 169, if they ask you for that, they're asking for just the positive root of that, which would be 13. But if you're solving an equation, the difference of two squares theorem says if you want to take the square root of one side and the square root of the other, if you're solving this equation, you take the square root of one side and the square root of the other, then you're going to get both roots, positive and negative 13. Okay, that's all for the difference of two squares theorem. Let's quickly move on now and talk about the Pythagorean theorem, which is much more famous. It's a classical one. You've probably already heard of it. In class tomorrow, we'll talk about who Pythagoras was, but he was a famous mathematician, Greek mathematician. His theorem says like this. If you have a right triangle, okay, so a triangle with one 90-degree side, we're going to call one of these legs next to the right angle, we'll call it A. The other leg next to the right angle, we'll call it B. And then the longest side, which is called the hypotenuse, we'll call C. The theorem does this. A squared plus B squared equals C squared. That's all there is to it. So in a real life example, let's say this was 3, this was 4. So you know that A squared, which would be 3 squared, plus B squared is going to equal C squared. If you do this, 3 squared is 9, 4 squared is 16. That's going to equal C squared. C squared equals 25. And then by the theorem that we just learned, the value for this would be C technically would be positive and negative 5, right? But you can throw away the negative 5 because it's the length. A length can never be negative. So the answer to us is our hypotenuse here is going to be 5. Okay, does that make sense? A squared plus B squared equals C squared. Now they might give you certain, they might not give you just A and B. Sorry, I shouldn't erase that. A squared plus B squared equals C squared. Let's say they give you a triangle and they give you 12 and 13, and we'll call this one A now. Okay? So we have the hypotenuse, we have one of the legs, but we don't know the other leg. So remember, if we write down our equation, I'll do it down here. A squared plus B squared, which is going to be 12 squared, is going to equal the hypotenuse squared. And now with algebra, you can solve this. Okay? Let me erase this. So I'm going to get 13 squared, which is 169, 12 squared, which is 144, and A squared, right? Take away the 144, you're left with 25 equals A squared. So A equals 5. So then you're able to fill in that one leg that we had. Remember, it looked like this. This was 12, this was 13, and so now we know that this one is 5. All right. There's some common Pythagorean, what they call Pythagorean triples. Pythagorean triples. A very common one is 3, 4, 5. What you'll find is 3 squared plus 4 squared equals 5 squared. And if you double any of those or triple them or, whatever, make it 6, 8, 10, that's also going to be a Pythagorean triple. Another good one is the one I just did, 5, 12, 13. Okay? So why don't you just memorize those? Memorize those couple and it'll come in handy. The last thing that they could do is they could ask you how to tell if something is a right triangle. They would say, if I have a triangle, and they don't tell you it's a right triangle, and they say, oh, this is 6, 7, and 9. Then they would say, is that a right triangle? Well, you know, because of this theorem, that if it was a right triangle, then 6 squared plus 7 squared equals 9 squared, and then you could try it out and test it that way. Does that make sense? And in this case, you'd find out that it's not a right triangle. Okay, so there's the lecture about the difference of two squares and also the Pythagorean theorem. And tomorrow in class, we'll do a few exercises on that.